This video is for my Algebra 1 class, and it is over Lesson 32, Simplifying and Evaluating Expressions with Integer and Zero Exponents. So ladies and gentlemen, let's dive in here. So first up, we're going to use the quotient property of exponents to help us discover a couple things. So let's consider x to the power of 3 over x to the power of 3. We should know that when we divide powers, we can instead subtract their exponents. So x to the third power divided by x to the third power is really x to the power of 3 minus 3. Now 3 minus 3 is very easy to do. It's 0. Now if we go the other way with this though, or a different way with this, x to the third power of x to the third power, that's something over itself. Anytime you have something over itself, the answer should be 1. So what we've just discovered here is that x to the power of 0, so anything to the power of 0 is 1. However, we've also discovered an exception to this. Since this is a fraction, you cannot have your denominator be 0. Therefore, x cannot be 0. So for x not equal to 0, anything else to the power of 0 equals 1. Go ahead and grab one of your highlighters. I don't care what color you choose. I happen to grab blue this time. This is our first property of today. Oh, I forgot the period on my sentence there. And this is called the zero exponent rule. At least that's what your book calls it. There are many different names for this. I've seen the zero property of exponents as a name as well. So just be a little flexible when you're thinking there. But this is what your book is going to ask you to call it. The zero exponent rule. And so our second property here of the today, we're going to take a look at now. So let's consider if we had instead x squared over x cubed. Well, once again, we know that this is going to be x to the power of 2 minus 3. 2 minus 3. Well, 2 minus 3 is really negative 1. But if I go a different direction with my thinking here, x squared really means x times x. X cubed means x times x times x. And so if I cancel out a pair of x's and cancel out a pair of x's, we can see that this is equal to, well, only 1 would be left up there and x down there. So x to the power of negative 1 is really 1 over x. Well, ladies and gentlemen, anytime you think about a variable like x, if we were to change this into a fraction, we treat variables like whole numbers. So just like 2 would become 2 over 1, x as a fraction would become x over 1. So a as a fraction would become a over 1, y as a fraction would become y over 1. So with that thinking in mind, we should see here then that 1 over x really is the reciprocal of x. So the negative first power creates a reciprocal, which leads us to our next property, which also, since this is explained through fractions, you cannot have 0 in the denominator. So once again, it's going to start with for x not equal to 0. And this one says x to the negative first power equals 1 over x. In other words, equals the reciprocal of x. And I'm going to grab a different color here for this property. And this property goes by, in your book, the rule for negative exponents. Now, related to this is that if I have x to the negative n power, so something other than 1, essentially that negative in the exponent is going to be like the fuel to create the reciprocal, to invert the fraction. Once the fraction has been inverted or flipped, that negative in the exponent gets used up. So this would equal 1 over x to a positive n. So creating that reciprocal basically uses up the negative in the exponent. So ladies and gentlemen, let's work through some examples now using these properties. So I'm going to put a little dashed line there. So let's say that I had, 5 to the power of 0. Well, by this rule, as long as the base is not 0, the answer is 1. If I had y to the power of 0, we would say the answer is 1, but we would be thinking that this is true so long as y is not 0, so long as y does not equal 0. If I had 5 times 4 plus 3 minus 2 divided by 7, and all of that in parentheses raised to the 0 power. Now just do a quick mental check, make sure that the base of this isn't going to end up being 0. Well, no, that's 20. That's going to be 2/7. So 20 plus 3 is 23. Minus 2/7, that's definitely not 0. So therefore, it's 1. Don't even need to simplify the inside stuff. I know the inside stuff's not going to be 0. That's good enough. Raise it to the power of 0, it's 1. By the way, ladies and gentlemen, if this does not make sense to you, that's okay. However, this is a time where if it doesn't make sense, you need to trust that it's true and accept it. And then you can, ask me questions later, get a hold of me, and I will do my best to try to give you some explanations for why this is true, other than our explanation up here. But when it comes down to it, things like this, sometimes we have to be flexible in our thinking and be able to accept what's true even if we don't understand why it's true yet. This might be the case for some of you on this one. All right, that's good. Let's take a look at some negative exponents now. I'm going to skip a couple lines there. So let's say we had x to the negative third power. So I would make a reciprocal, 1 over x, but then the third power would stay with that x, but now it's a positive. Let's say we had 2x to the negative third power, though. In this case, we need to remember that exponents only happen to whatever they are directly next to. So if I have my 2x to the negative third power, this exponent here is directly next to the x. It is not affecting the 2. So that means that my x to the negative third power is, like we did in that last example, going to become x 1 over x to the positive third power. My 2, however, being left alone, if I make that a fraction as well, would just be himself over 1. And we're multiplying these together. So ladies and gentlemen, kind of a shortcut here for problems like this is if I take my 2x to the negative third power and I imagine it as being a fraction, being over 1. What the negative exponent is basically going to end up doing is it's going to take anything that it's affecting and flip it from numerator to denominator, denominator to numerator. And so this will end up equaling, well, if I just take this x to the negative third power and put it on bottom, that means the 2 is still on top. And so my answer here, if I can slide my paper back up, would be 2 over x to the negative, or excuse me, to the positive third power now because I flipped it. So only that x to the negative third power will flip to the denominator. So let's say we had 4x to the negative third power again, y squared. So the negative third power is only affecting x. So if we imagine this is already being over 1, then the 4 and the y squared, they don't have negative exponents, they're going to stay on top. So 4y squared stays on top, and then the x cubed will flip to the bottom and become positive. So 4y squared over x cubed. All right, let's get a little bit more complicated now. Let's say I had 5a to the negative second power, b, c to the negative first power, d to the negative third power. So once again, the only things that are going to move are going to be the things that have negative exponents. Everything else is going to stay in that numerator like we imagine it being. So 5 does not have a negative exponent, b does not have a negative exponent. They're going to stay on top. A to the negative second, a to the c to the negative first, d to the negative third, then we're going to all flip to the bottom and get positive exponents. So now this will be 5b over a squared. C to the first would just be c, and then d cubed. So 5b over a squared c d cubed. And I'll come back through here and circle my answers. All right, we're going to take a look at a few more here. Just for the sake of really being able to see what's going on, I'm going to start double spacing these because we're going to look at some fractions. So let's say I had 7e to the negative 7th power f cubed all over 6 g squared h to the negative first power. So once again, the only things that are going to move are those things that have a negative exponent. So negative exponents make reciprocals. Reciprocals means the fraction inverts. In other words, a numerator becomes a denominator becomes a numerator. So when I look for my negative exponents, the negative exponents on the e and the h, those are the only things that are going to move then. So 7 and f cubed are going to stay right where they are. But then this h to the negative first power is going to become an h to the positive first power, or just h, up top. On the bottom, 6 and g squared are going to stay on the bottom, but it's this e to the negative 7th power which will flip to the bottom and become a positive 7th. And I like to put these in alphabetical order. It just kind of standardizes our terms for us, our variables. All right, next up, let's take a look at, I got some room here. Let's do x, y to the negative 3rd power, z to the 5th, all over x squared, y squared, z. Now there are several different ways that this could be simplified, and so I'm going to show you one of them here. One of them, which is a good idea, is just to start by taking care of the negative exponents. Now in this case, there's only one negative exponent. It's the y to the negative 3rd power. So I'm going to leave my x and my z to the 5th up top. And on bottom, I'm still going to have an x squared. I'm still going to have a z, but now we've got this z squared and we've got a z cubed that's going to come down and join it. Or excuse me, y squared and y cubed. So y squared times a y cubed will give me a y to the 5th power. Now from here, I would want to do a little bit of reducing. So as far as my x's were concerned, my x up top would reduce with an x on bottom. So it'll leave me with just an x on bottom. And then I'll still have my y to the 5th power, because that's the only y's I have are all on the bottom now. But then z to the 5th and z can reduce, so this z and one of those z's will reduce, so it'll be a z to the 4th power up top. And now my fraction bar is a little big. I'm going to erase a little bit. All right. So let's take a look at some numbers again. 3 to the negative 4th power. So this would become 1 over 3 to the 4th power. And 3 to the 4th power, well, 3 times 3 is 9. 3 times 3 is 9. And 9 plus 9 is, or times 9, is 81. If I had 2/5 in parentheses to the negative 1st power, this is going to tell me to flip the entire fraction. And so I'd get 5/2, or 2.5. All right, next up, let's say I had 2/5 this time, but without the parentheses. So remember, without the parentheses, the exponent's going to happen only to what it's directly next to. In this case, the only thing it's directly next to is the 2, the numerator. So this means that my numerator is going to flip down to the denominator, and the 5 is still there. Now, what fills that empty space? Well, 1s. And so 2 times 5 is 10. And just for good measure, let's say I had 2 over 5, and very obviously it was 5 to the negative 1st power. And in this case, the 5 to the negative 1st power would flip to the top, and I'd have 2 times 5, and that empty space then would be filled with 1. 1 on bottom means it's a whole number. 2 times 5 is 10. All right, on to the back. We're going to tackle a to the 5th power, b to the negative 2nd, c to the negative 3rd, d, and then all of that to the negative 4th. And there are actually a bunch of different ways that we could simplify this. And so we'll take a look at a few of those. One way to simplify this is to actually distribute this exponent into each of your factors. So if I distribute that negative 4 factor, and remember, a power to a power, we're going to multiply these. So 5 times negative 4 would give me a to the negative 20. B to the negative 2nd power to the negative 4th power, well, negative 2 times negative 4 gives me a positive 8. For C, I've got a negative 3 times the negative 4 would give me a positive 12. And finally D, which is really D to the 1st power, so 1 times negative 4 would be negative 4. From here, we would want to simplify it further by taking care of those negative exponents. So if we kind of think of this as being itself over 1, then anything with a positive exponent is going to stay up top, and anything with a negative exponent will go to the bottom, which uses up its negative exponent. So b to the 8th, c to the 12th, over a to the 20th, d to the 4th. So let's try it again. Try a different method. And again, there are a bunch of different ways to solve this. Another way to deal with this is to first take care of your negatives inside. So if I take care of the negatives inside here, then I'm going to end up with a to the 5th d, which will stay on top because they're positive exponents, over b squared c cubed. But that still needs to be raised to the negative 4th power. So from here, Again, we have a couple options. I could distribute the -4 to each of those. So if I distribute the -4 now to each factor and each of my things I'm dividing by, each of my divisors, I can make this a to the -20th, d to the -4th, over b to the -8th, c to the -12th. Well, now everything has a negative exponent, so just move everything. So if we switch everything around, I'm now going to have a to the 20th, b to the 4th on the bottom. I'll have b to the 8th, c to the 12th up top. And if you compare the two answers, we got the same thing, which of course we should. All right, one more time, just to show you options. We have lots of options. Let's say we took the same first step. Another option here would be to go ahead and take care of that negative in the -4. Oops, I forgot the -4 there. So the negative we know is just going to make a reciprocal. So let's do a reciprocal. So b squared c cubed over a to the 5th d. Now the moment I take that reciprocal though, that negative in my exponent, that negative in the -4, is used up. And so all that's left is a +4. Now if I distribute this exponent into each of the factors and divisors, 2 times 4 gives me a b to the 8, 3 times 4 gives me a c to the 12th, 5 times 4 gives me an a to the 20th, and an invisible 1 times 4 gives me d to the 4th. And again, if you compare it to the other answers, it's also the same thing. So ladies and gentlemen, problems like this can be solved in many different ways. Just make sure that you are careful about moving things if they have a negative exponent and not moving them if they have a positive exponent. And that, ladies and gentlemen, is our lesson.